Good day, students. How are you? Continue our lesson. Next topic is the reduced Laplace function. The reduced Laplace function. Nazaricis çevrilmiş Laplace fonksiyası. This function has the following form and it is expressed by means of error integral. Phi capital tilde. This symbol is read as tilde of x is equal to phi capital of rho x. It is read as tilde. Then we can also we can express the error integral itself by means of Laplace function. If take x over rho instead of x in this formula, then we will have phi tilde of x over rho is equal to phi of rho multiplied by x over rho. Here the argument of error integral is will be simplified by rho. Then we will obtain the expressing the error integral by means of reduced Laplace function. Phi x is phi tilde of x over rho. Then remember the formula of probability of following the continuous random variable with the normal distributive density into the symmetric interval a minus L, a plus L. Remember this formula, P capital, that continuous random variable will be situated between a minus L and a plus L. A plus L is equal to phi of rho multiplied by L over E capital or epsilon capital. Use this formula and express this probability by means of the reduced Laplace function. P of a minus L is less than x is less than a plus L is equal to phi, and must substitute rho multiplied by L over epsilon capital instead of x. Phi tilde rho multiplied by L over E over rho. Here the argument is simplified by rho, and then we'll obtain finally P that a minus A is less than x is less than a plus A is equal to phi tilde of L over E. This is our final formula. Continue. For next topic is for E capital or sigma capital rule. Use the formula of the probability that continuous random variable with a normal distributive density will be situated inside the symmetric interval by means of reduced Laplace function. P that a minus a is less than x is less than a plus l is equal to phi tilde of L over E capital. If take L equals 4 E capital, then we will have P of A minus 4 E is less than x is less than a plus 4e is equal to phi tilde 4e over e capital. Then simplify the argument by e capital. Then we will obtain phi tilde of 4. And according to the table of reduced Laplace function values, we will obtain that it is approximately is unit. It is approximately is 0.99, or also we can take approximately unit 1. It means the continuous random variable with the normal distributive density is always will belong to this symmetric interval. And also you know that the probability that the continuous random variable will belong to the symmetry interval doesn't depend on the symmetry center, and therefore we can take a as 0, a equal to 0. They will obtain P capital Z minus 4e is less than x is less than 4e is approximately equal to unit. This formula is named the 4e rule. Then we can construct the probability dispersion scale. The probability dispersion scale. Dispersion scale. It is in Azeri etmaların səpələnməsi şkalası. Scale şkala, dispersion səpələnmə, probability etmalların səpələnməsi şkalası. Now construct the scale. And then construct the normal distributive density whose symmetry center is situated at origin. You know that this normal distributive density is graph of this density is symmetric with respect to y-axis, ordinate axis. Y is equal to 1 over sigma square root of 2 pi multiplied by e to minus, here a is 0, minus x squared over 2 sigma squared. Let remember the definition of median deviation. Median deviation is denoted as is denoted by the capital Latin letter E, or capital. Also, it is read as Greek capital Greek letter epsilon. Epsilon. According to the definition of median deviation, the probability that continuous random variable with the normal distributive density will fall into the interval from minus e capital to plus e capital is equal to 1 second. Exactly is equal to 1 second. Let it is e capital, and then it is minus e capital. The probability is the area is equal to the area between the graph of normal distributed density and x-axis, and it means the area of this figure is 0.5. But our graph is symmetric with respect to ordinate axis. Then it means that areas, both areas, right and left areas, are exactly equal to 0.25. And whole area is exactly equal to the 0.5 according to the definition of median deviation. Median deviation. Then, according to the tables, to the table of the reduced Laplace function values, we have that that the probability that continuous random variable with a normal distributive density will be situated in the interval e capital to e capital is approximately equal to 0.16. Approximately 0.16. Then probability that continuous random variable with a normal distributive density will be situated in the interval 2e capital, 3e capital, 3e capital, approximately is equal to 0.07. And finally, according to this table, the probability that continuous random variable with the normal distributive density will be situated in the interval 3e 4e is approximately equal to 0.02. And the probability that continuous random variable will belong to the interval 4e plus infinity is approximately equal to 0. And it means the continuous random variable with a normal distributive density will never fall into the interval for e capital to plus infinity. And our graph is symmetric with respect to y-axis, therefore the corresponding symmetric probabilities will be will be identical ones. That is, the probability that continuous random variable will be situated in the interval minus 2e capital minus e is approximately 0.16. Then the probability that the continuous random variable will be situated in the interval minus 3e minus 2e is 0.07. And finally, the probability that continuous random variable with continuous random variable will be situated in the interval minus 4e minus 3e is approximately equal to 0.02. And finally, that probability that continuous random variable will be situated in the interval minus infinity to minus e is approximately equal to 0. Finally, it is a probability dispersion scale, and the final idea is that probability the continuous random variable with a normal distributive density will be situated in the interval minus 4e. 4e is approximately unit, because if summarize the indicated probability, we will obtain unit. 0.25 plus 0.16 plus 0.08 and plus 0.02 is approximately 0.5, and 0.5 twice 0.5 is unit. It is the probability dispersion scale. The next heading is the mean arithmetic error. The mean arithmetic error. The mean arithmetic error. Mean arithmetic error in Azeri it is orta adadi səhv. The mean arithmetic error. This value is denoted as D, and according to its definition, it is the mean arithmetic error is a mathematical expectation of the modulus of the deviation of continuous random variable. That is, it is m modulus x minus mx. It is a definition of the mean arithmetic error. Remember that the mathematical expectation of the continuous random variable with the normal distributive density is equal to the symmetry point. That is, mx is equal to a. Here a is symmetry point. It is symmetry point. Symmetry point. We can rewrite this formula. D is mx minus a. Then remember the formula of mathematical expectation for the continuous random variable. mx is is improper integral from minus infinity to plus infinity of x multiplied by f of x dx. It is formula of expectation for the continuous random variable. Then substitute modulus of x minus a instead of x. Then we will have d is equal to integral from minus infinity to plus infinity of modulus x minus a multiplied by f of x dx. Then we can separate this integral into the two integrals. One of them is taken from minus infinity to a, and second integral is taken from a to plus infinity. Plus infinity equals integral from minus infinity to a of modulus x minus a multiplied by f of x dx, plus integral from a to plus infinity of modulus x minus a multiplied by f of x dx. Then remember the definition of modulus or absolute value. Here in this integral x is less than a. If x is less than a, then x minus a is less than 0, and according to the definition of modulus, it means modulus x minus a is equal to minus x minus a, or equals a minus x. Then here in the second integral, the integral variable is changed from a to plus infinity. It means the integral variable is greater than a. X is greater than a. It means then x minus a is positive, and according to the definition of modulus or absolute value, modulus of x minus a is equal to simply x minus a. Then continue. Consider these changes in our integrals equals. In the first integral, we can write a minus x instead of modulus of x minus a. Integral from minus infinity to a of a minus x multiplied by f of x dx, plus integral from a to plus infinity. In the second interval, we can write x minus a instead of modulus of x minus a. X minus a multiplied by f of x dx. Then continue. We can make the following change. Let a minus x is t. Change. First change, because we will have several changes. First change. A minus x is t. Then x minus a is minus t. From here we'll have x is a minus t, and dx is d of a minus t, and you know that the differential of the difference is the difference of differentials. It is dA minus dt. Here a is constant value, it is 0, 0 minus dt, and we will obtain simply minus dt. Then also we change the integral limits. In the first integral, the lower integral limit for x is minus infinity. If x is minus infinity, then according to this change, a minus infinity is a plus infinity, and a plus infinity is plus infinity, because if add the constant value to plus infinity, then we will obtain again plus infinity. T is plus infinity. Then if x is a, then if substitute a instead of x, we will obtain a minus a is 0, t is 0, t is 0. And finally, if x is plus infinity, then t is, substitute plus infinity instead of x, a minus infinity, minus plus infinity is a minus infinity, and just a, t is minus infinity, because if add the constant value to minus infinity, then we will obtain minus infinity. Minus infinity. Here our change ended, and then apply this change to both integrals. Integral from plus infinity to 0 of t multiplied by f of a minus t multiplied by minus dt, plus integral from 0 to plus infinity of x minus a is minus t multiplied by f of where's x, x is a minus t multiplied by minus dt. And continue. Here we can take negative sign out of the integral symbol. Then we'll obtain minus integral from plus infinity to 0 of t multiplied by f of a minus t multiplied by dt. Then minus negative sign multiplied by negative sign will be the positive sign, plus integral from 0 to plus infinity of t multiplied by f of a minus t multiplied by dt. Continue. Then we can change the places of place of the integral limits of the in the first integral. And in this case, the sign of this integral will be changed. Integral from 0 to plus infinity t multiplied by f of a minus t dt, plus integral from 0 to plus infinity of t f of a minus t dt. We obtained two identical integrals, and it is equal to twice integral from 0 to plus infinity of t multiplied by f of a minus t dt. Then continue. That is D is notation of the mean arithmetic error. twice integral from 0 to plus infinity of t multiplied by f of a minus t dt. Then continue. Then remember that the normal distributive is the symmetric with respect to a, and it means f of a minus t is equal to the f of a plus t according to the definition of a symmetric function. And we can write f of a plus t instead of a minus t. We write twice integral from 0 to plus infinity of t multiplied by f of a plus t dt. Then make the second change. Change a plus t by x. Second change, write second change. Let a plus t is x. A plus t is x. Then t is x minus a, and dt is dx. Simply dx. Then consider the integral limits. If t is 0, then substitute 0 instead of t, x is a. And if t is plus infinity, if a plus infinity is simply plus infinity, x also is plus infinity. Apply the second chain to the last integral. Twice integral from a to plus infinity of where is t, x minus a multiplied by f of x dx. Then substitute the expression of normal distributive density instead of x. Remember the formula of normal distributive density. F of x is 1 over sigma square root of 2 pi multiplied by e to minus x minus a squared over 2 sigma squared. This is the expression of the normal distributive density. Substitute this expression instead of x. Equals twice integral from a to plus infinity of x minus a multiplied by 1 over sigma square root of 2 pi multiplied by e to minus, we can rewrite this exponent as minus x minus a over sigma square root of 2 squared. X minus a over sigma square root of 2 squared equals. Then substitute, then change this base of the power by new variable t, and it will be the third change. X minus a over sigma square root of 2 is t. Then x minus a is equal to sigma square root of 2t. Then x is x is a plus sigma square root of 2t, then dx is d of a plus sigma square root of 2t. You know that the differential of sum is the sum of differentials, dA plus d of sigma square root of 2t. dA, differential of the constant value is 0 plus, and it is constant factor sigma square root of 2, which can be taken out of the differential symbol, sigma square root of 2 dt, and finally we have simply sigma square root of 2 dt. And we can consider also the integral limits if x is a. Then substitute a instead of x. A minus a is 0, t is 0. And if is x is plus infinity, then substitute plus infinity instead of x, then we will have plus infinity minus a is plus infinity divided by positive value is also plus infinity. T is plus infinity. Apply the last change to the last integral twice, multiply integral from 0 to plus infinity of sigma square root of 2 multiplied by t multiplied by 1 over sigma square root of 2 pi multiplied by e to I'm sorry, here we must write also dx is e2 minus t squared and multiplied by sigma square root of 2 dt. Then here we can simplify the coefficient of integrand by sigma square root of 2. Then we will have the following values. Then continue. Then we can take 1 over square root of pi and sigma square root of 2 out of the integral sign, integral symbol, equals 2 multiplied by 1 over square root of pi multiplied by sigma square root of 2 multiplied by integral from 0 to plus infinity of t multiplied by e2 minus t squared dt. Then continue. Then we will have sigma square root of 2 over square root of pi twice integral from 0 to plus infinity of t to minus t squared dt. Then introduce 2 into the integrand. Then we will have sigma multiplied by square root of 2 over pi, the integral from 0 to plus infinity of e to minus t squared to t dt. And you know that the 2t dt is dt squared according to the anti-differential table. Then equals sigma multiplied by square root of 2 over pi is equal to the integral from 0 to plus infinity of e to minus t squared dt squared. Then we must introduce the negative sign into the differential symbol, and at the same time we must put the negative sign in front of the coefficient of integral. Minus sigma square root of 2 over pi multiplied by integral from 0 to plus infinity of e to minus t squared d of minus t squared. Then this integral is d of e to minus t squared. Integral from 0 to plus infinity of d of e to minus t squared, and here antiderivative is e to minus t squared minus sigma multiplied by square root of 2 over pi multiplied by e to minus t squared with the double substitution from 0 to plus infinity. Then rewrite this exponent in the natural form, minus sigma multiplied by square root of 2 over pi multiplied by 1 over e to t squared with the normal distribution, with the double substitution from 0 to plus infinity. Here we must first substitute plus infinity instead of t, and then substitute 0 instead of t. Equals minus sigma square root of 2 over pi multiplied by e to plus infinity squared minus 1 over e to 0 squared. Plus infinity squared is plus infinity. E to plus infinity is plus infinity. 1 over plus infinity is 0. And 0 squared is 0. E to 0 is unit. 1 over 1 is 1. And then we will have minus sigma square root of 2 over pi multiplied by 0 minus 1 and equals, then continue. Minus sigmas multiplied by square root of 2 over pi multiplied by minus 1. And finally we will have that d, that the mean arithmetic error is simply sigma multiplied by square root of 2 over pi. It is our result. Then continue. Our last topic is named the accuracy measure. The accuracy measure. Accuracy measure. Accuracy measure in other it is dakikliği ölçüsü. Dakikliği ölçüsü. Accuracy measure. Remember the formula of the normal distributive density. F of x is 1 over sigma square root of 2 pi multiplied by e to minus x minus a squared over 2 sigma squared. It is the formula of normal distributive density. Then rewrite this formula in the following form. F of x is equal to 1 over sigma square root of 2 multiplied by 1 over square root of pi multiplied by e to minus minus 1 over sigma square root of 2 squared and multiplied by x minus a squared. Then denote this value by new notation h. Let it is h. Then we can rewrite the formula of normal distributive density in the following form. F of x is h over square root of pi multiplied by e to minus h squared multiplied by x minus a squared. Here h is named the accuracy measure. It is accuracy measure, and we see from this formula that the greater h, the greater h greater the maximum of normal distributive density, and the less the dispersion of probabilities. It was our the last lesson. Our lesson ended, and good luck, dear students. Goodbye.